pick up where we left off, and we were just talking about Wi-Fi and how it's generally easy to use, but also easy to observe or attack. So why don't we try a little learning exercise hands-on on what you can observe with Wi-Fi signals around you. So the testing environment is going to be pretty simple. The goal is going to be observe Wi-Fi network traffic around you, be able to filter and isolate specific traffic going from one device to a specific website, and then see if you can observe some clear text, username or passwords, or text in general being sent from that device to that specific website in an HTTP request. So the requirements for this is pretty simple. You need a Wi-Fi hotspot or a Wi-Fi router that you have access to and hopefully you own. And then you're going to need a tool named Wireshark installed on your computer. We really prefer that you use your own Wi-Fi hotspot or router just so you're not kind of sniffing other people's traffic. Wireshark is a pretty industry standard tool for observing network traffic. It's used for a lot of good things. Specifically, people use it to troubleshoot network errors or performance errors or issues, analysis of how protocols work or understanding how they work, both for a commercial endeavor as well as just for education. And then unfortunately, people also use it to sniff or observe traffic for nefarious reasons. So we're going to do it for education here. And the first thing you'll need to do is download Wireshark if you don't have it, and the link is included here. So again, just to reiterate, prefer to use your own local Wi-Fi network, whether that be a router that you have access to or a hotspot that you can spin up on your mobile device that your computer can connect to. And then just make sure to only observe your own traffic, traffic that you are generating from your own devices. So let's take a look at a sample website we have here. So one thing I'll do is I'm in Windows right here, and to make it simpler, we're going to use IPv4. And so if you have Windows, you might do this because you don't want to deal with IPv6 addresses per se. You can just come here to Internet Protocol version and just disable that and hit OK. I'd already done that. It's not a big deal if you haven't. You're likely using IPv4, but if you're using IPv6, you'll see numbers and letters with colon marks instead of just numbers and periods. But either way, it kind of works for this. So that's one part of the setup. And then once you have Wireshark open, you'll be able to click this button here, start a new capture, and you'll notice that your computer is sending things in and out without you doing anything, because these days there's so many programs connecting to the internet on their own, like your email clients, updates for Windows or Mac, etc., etc. This all goes on in the background, and a lot of content's being generated. So it's going to look confusing. There's a lot of buttons here, a lot of ways you can look at this data. We're going to just do a very simple filtering exercise and following an HTTP stream. So there's a test website I have running here. What we're going to do is load this up, continue. And the first thing you'll notice is there's so much content going on in Wireshark. How can I even start figuring out which content I want to look at, and how do I kind of isolate the content I want to play around with? Well, the website I just showed, security.enablingprogrammableself.com, is the website. You'll notice Wireshark doesn't use that name, right? It's using IPs like we discussed before. So DNS is being used to figure out what IP that maps to. And so, let's try to find out what IP that maps to. So whether you're in Mac or Windows, you can kind of fire up the terminal. So in Windows, it's pretty easy. Just hit Command. Mac, there's the program called Terminal. And in either of those, you can just do this, ping. And let's go back to the website and capture the domain. Ping is just a standard utility to see whether the domain you're trying to access is reachable. And here we go. We'll just go ahead and take off the HTTP because we're not in a web browser, we're in in a terminal here, and you'll notice that it's just asking, hey, are you live, and how long does it take you to respond to me? What we're interested in here is finding out the IP, and luckily it gave us the IP right there. So why don't we copy that? And if we come back to Wireshark, we now can start to try to filter some of this. So if you were to start typing in, right, we want to filter on an IP. Wireshark's pretty easy to use. If you start typing in IP, it's going to start showing you different ways you can filter using IP. So we're going to filter on the destination, right? We're trying to reach that website. So we'll just do equals equals. And now only the traffic going to that website will show. That's pretty good. Now, potentially, if you're in like a busy cafe and this website was really popular, you might have multiple people trying to get to that IP. In this case, it's only you, and this website's not that popular, so you won't see a lot of different traffic. In fact, there's only one source, right? This source is actually your IP. But you can always confirm that by going to your network properties. So in Windows, let's go here, kind of right-click on this network connection, look at status, and you can look on details, and sure enough, like here's my IP address. Yep, that looks like the same thing. So we know that's me. And that's on the Wi-Fi adapter, right? Okay, so for the sake of this exercise, we'll also filter on, and you'll just use it with an and, saying like, I want to filter on two things, IP.source. And let's filter on 192.168.1.32. So now we're looking at transactions that are leaving my laptop and reaching that specific website. And that's all we're looking at. So that should really clean things up. Let's save that. Actually, it's technically saved in my filter history, but let's start this again because it's already kind of messed up with my test transaction. So if I do this and say continue without saving, okay, we have a nice clean log with our filter enabled. Let's go back to that website. All right, so we're gonna hit instead of reload, I'm gonna hit enter here because reload might actually keep a cache in the browser and not actually show us exactly what's going on. So if I hit enter on this, it just brought up this web page. And if I go back to Wireshark, let's see what we have here. We had mentioned in the lecture, right, that the protocol used often for HTTP to connect is TCP. So the first thing that happened is my computer, well, the first thing that happens is my computer had to figure out what's the DNS entry for this programmable self website, programmableself.com. It did that, and now it needs to set up a connection. This is kind of like the handshake for TCP to set that up. And then the next thing it did is, hey, I want to get the content for index.php. You'll notice that's the resource we're asking for. So let's look at this. You can kind of see it, Wireshark gives you a bunch of information. It has the TCP level information on packets and frames going forth, what internet protocol version you're using. So like I mentioned, IPv4. If it was IPv6, this would be a bunch of numbers and letters with colons in between, which you can also filter on. But for this sake, I did IPv4, which is simple. We know that it's using TCP. There's some other information that once you get into TCP, you'll understand, like ports for the source and destination. And then we have HTTP as the protocol we're using at the browser level. You'll notice that we sent a GET request, and does a pretty nice job of showing a readable version of this. If you're actually to look at the raw data going across, you'll notice that a lot of this isn't very easy to read. And so one thing you can do is click on this, right-click on this, and say follow. You can either follow the TCP stream or HTTP stream. In this case, since we're working in a browser with HTTP, we'll just go ahead and do this. And sure enough, you can see this in a much more readable version, right? We did a GET request. The server responded with a, OK, 200 OK. There's no cookie being used here. I've never visited the site before. It doesn't actually want to leave a cookie. So it's not trying to remember me or personalize my results. and then it sent back, the HTML that the browser interprets to actually produce the page that we see here. And like I said, you fire off one GET request and it might fire off one response from the server, which might actually tell you to do more things. So if you were to look at this HTML, it needs to find what the script is. Oh, well, this is a text JavaScript and the source is here. It actually requires the browser to ask for that so it can keep loading the page and more elements. So that's the next GET request. This one says, not modified as a response from this website, meaning I've visited this website before and it's in my browser cache, so just keep using that. More and more things were requested here. There's a little bug in our test website saying this one little component's not found, but that's okay, it won't really prevent us from doing this exercise. So let's go back to the website. This is a test website, but something you might have seen before, an email and password prompt. In this case, it's not secure, so there's no SSL involved here. There's nothing encrypting the content going to and from this website. So if this was a poorly coded website and it's asking for your email and password, that would already be a huge red flag to not proceed. But for the purposes of this exercise, let's just say you were to type in a fake email and password. Okay, I'll hit submit. This website does nothing but reload the page, so not very exciting. But let's see what happens in Wireshark. A bunch of more transactions came and went. And we're following the HTTP stream already, so if we scroll back up, we should be able to see another GET request. Oh, sorry, we have to kind of figure out where we requested again. So let's go scroll all the way to the bottom and just work our way backwards. So here's a GET request, but that was for the little JavaScript object. We want to look for the actual web page. Here's a GET request. Oh, I see what I did. So this is a good little exercise. I'm not seeing the GET request. We should really be seeing a POST request because we didn't just get something, we also posted some content. And that content was our username and password. So why don't I see that? Because I'm buried in this TCP stream where I tried to follow the stream. So let's go back out and change the filter. Change our filter back to where we had it before. My machine and the website. And that's all we're going to filter on. So if I do that and hit enter, we'll see all the transactions again. And let's look if you can see a post. There's a post. And let's follow, like we did, that TCP stream, or that HTTP stream, so it's easier to read. And sure enough, now we have something easier to read, and let's see what we can see here. So unlike last time where we did a GET request, we're actually adding some information. So we're not just asking for the homepage. This time we're posting some information, the email and the password, and then asking the server to respond with some updated content. And so you'll notice that we have a HTTP post, and there's some content here, and you'll notice there's actually a body to this content. And in this case, it sent an email and a password. So not very good that it sent it in clear text, huh? But while most of the internet's moved to HTTPS for all traffic, and of course, even back in the day, email and password is usually encrypted with HTTPS. For this exercise, we notice that it's not, and sure enough, you'll see exactly the email and password just sitting there. The @ sign is encoded here, but essentially you can figure out whose email this is and whose password it is. So in this very simple example, right, you can see how you can sniff some Wi-Fi traffic and observe some content being uploaded from the device that you're controlling. And if you were to do this on Google, you're not going to see this. It's all encrypted these days. But once in a while, you'll see a website that doesn't use HTTPS, and you'll be able to see this. Even if you are looking at HTTPS websites, you'll be able to still see quite a bit of header information, right? Which IP it's coming from, what are they asking for, what resources are they asking for, And some of the body responses will be encrypted, some won't. If it's HTTPS for the whole website, then you won't see much of the body at all. It'll all be encrypted, but it's still very interesting to see what content's coming back. In this case, it's just clear text, HTML, like the JavaScript object is being asked for here again. Once again, our website has a little bug, but I think this is a useful exercise just to get your hands a little dirty with Wireshark and to see what else you can do. And if we come back here and get out of our followed HTTP stream, we'll now see all the content going to and from my computer again. You'll see, wow, like there's a bunch of stuff going on. And so you can see the power of filters to get rid of all that noise. So that's the end of this exercise. Hopefully you've understood the goals, and make sure to, again, do this on devices you own and traffic that you control, not other people's traffic, because you have no idea what they're going to. You could be going to their bank, you could be going to something sensitive, and you don't really want to observe that traffic. Okay, thanks for trying the exercise with me.